Hello everybody and welcome to the third episode of the Grad School Chronicles. I'm currently packing to get my ass to the university and do a bit of work, and I thought I would make another video. Now it is a love-hate relationship for me with commute to the university, because on an average day it takes me about an hour to get there. I live pretty far, but in my undergrad days, this actually was quite beneficial because I would often leave reading the lab manual or course material to the last minute to do it on the train during my commute. But during the grad school days, things have changed a little bit, and now I'm just extremely bored on the train. So what I've started doing recently is just trying to sleep on the train. Kind of get my brain to relax a little bit from a hard day of work in grad school. That's a joke, by the way. But sometimes it's kind of hard for me to fall asleep on a train. I mean, there is a whole bunch of things happening. People talking, the doors opening and closing, and all that kind of stuff. So in order to help myself, I've started, whether by my own choice or accidentally at some point, I started going through math problems in my head. It's kind of an equivalent to counting sheep, I guess, before you fall asleep. Doing simple algebra in my head seems to do the same trick for me. And I gotta say, I'm not that bad at math, so really for me to get into the mood where I start getting tired from doing math, it takes a little bit of effort. So generally speaking, I start dividing numbers one by another in my own head, and I would pick something like 10,023 divided by 13 and start going through that math in my own head until I confuse myself and I start losing track of numbers and I just fall asleep. And it is one of these math problems that I want to tell you about today. So a couple of weeks ago, I think I really outdid myself. I decided to divide an 8-digit number by some other number. And what better 8-digit number to use for this than my student ID. And the interesting thing about my ID is that it ends in the number 87, so that's of course divisible by 3. So I thought, well, an 8-digit number is hard enough to start with, so I'm just gonna try and simplify my task and just try to divide it by 3. And in the process of doing that, I've realized that I think things are actually working, but my half-asleep brain started doing something entirely different to divide this number by 3. And that's something that I thought I'd share with you today, just for fun. The weather outside today looks pretty nasty, so I don't think I want to ride the train. It's really cold and humid, which is unlike Calgary at all. I think I'm gonna jump into the car and just drive to the university. What kind of long commute is it without a good cup of coffee? Well, not that Tim Hortons is really good coffee, but it's warm. That's all I care about right now. Hi there, can I get a large coffee with 1 sugar and 2 creams? That's all. Thank you. So the funny thing about this problem that I'm about to tell you a little bit is that I ended up not falling asleep on the train at all because I got so excited by trying to figure this thing out that yeah, the whole way home I was just sitting there doing mental math and being amazed at how things are actually sort of working out. So defeated the purpose a little bit. So here we are at my favorite place in the world, the University of Calgary. Another joke, if you couldn't tell. I don't mind this place, honestly. But I guess to tell you a little bit more about this math adventure that I've had. So what ended up happening is that this 8-digit number, which is my student ID, I started to try and divide it by 3 in parts. So I would take a couple of digits out of this number and see if it makes sense that they're divisible by 3. Oh, and it's cold. And to my surprise, at some point, I instead of dividing things by 3, because some of the digits in this number are things like 10. You know, obviously it's not going to be divisible by 3. So what I started doing instead is trying to see if I can represent these numbers only using 3s. So using simple math operations like addition, subtraction, multiplication, division, and taking things to some power. You know, I ended up realizing that actually I can. And I'm sure there is a math term or theory that describes this process, but I don't know what it is. But I got a lot of enjoyment out of doing that. So I thought I'd share it with you. And what I want to do today is to actually try and write out my answer. But for that, as you can guess, with a number that has 8 digits and trying to represent it only using the number 3 and doing a bunch of operations on it, that's gonna take quite a bit of room. So I need a big old blackboard, which we just happen to have in our office. So that's where I'm going right now. Yeah, I pretty much work in a dungeon, so that's always fun. Good old blackboard, that's just what I need. Alright, so here we are. Let's try this out. So, for reference, I guess I should probably give you my number which I'm working with. So, let's just put it right on top here. Okay, so that's the number. It's 10102787. It is my student ID, but you know, if you want to steal my graduate school identity and come suffer for me, you're more than welcome to do so. Anyway, so the idea behind this is to represent this number using simple math operations and using only the number 3. So what I mean by that is, let's just do the first 2 digits, which is 10. So 10 is not divisible by 3 in a nice way. However, we can write it in terms of 3's, like so. So it's 3 times 3 plus 3 over 3, right? Gives us 9 plus 1, that's 10. So I think we're off to a good start. Obviously, we can do 27. 27 is just 3 times 9. So actually that's even easier. That's 3 times 3 times 3. Or even a more neat way to do this is 3 to the power of 3. That gives us 27. And last but not least is 87. So 87 we can do, it's 3 times 29. Or we can do 3 times 30 minus 3. That's a good start. And 30 is 3 times 10, and we already know what 10 is. So let's try to do that. It's 3 times 3 times bracket 3 times 3 plus 3 over 3 bracket. So that gives us 30 times 3, that's 90. So we take away 3 from that to get 87. So that's pretty fun. But I think I can take this to the next level and actually try to come up with an equation, some sort of equation using this way of doing math, which is going to give us the 8-digit number which I'm looking for. I'm gonna try to do that right now. Okay, so I think this may be it. Let's just try and do the math. So the first term here is 3 times 3 plus 3 divided by 3. So that gives us 10. And it's to the power of 3 times 3. So that's 9 minus 3 over 3, which is 8. So 10 to the power of 8 gives us, I think I'm going to use white chalk because red doesn't show up very well. So 10 to the power of 8 gives us, of course, whatever that's going to be, 100 million. Sounds about right. Too many zeros. 1, 2, 3, 4, 5, 6, 7, 8. Okay. That's a pretty good start, is it? We have the whole number as 8 digits. So that means we are running too many zeros. Too many zeros right now. Okay, so I already screwed up on my very first step, but that's okay because all we need to do is to bring this guy to the power of 7 instead of the power of 8. So how am I gonna do 7? What's gonna be the best way to do it? Let's do it like this. 3 plus 3 plus 3 over 3. Okay, so that should work because that's 6 plus 1, that's 7. So then now our number has 7 zeros at the end of it, so that looks about right. Now it's overall an 8-digit number. Okay, so we deal with that. So plus 3 times 3 plus 3 over 3 to the power of 3 plus 3. So inside here is 10 and here is 6. So again, I think I started off with too many zeros, so this should realistically be to the power of, to the power of 5 instead of 6. So what we're gonna do here is just do 3 plus 3 minus 3 over 3. So that's 6 minus 1, which is 5. So now we add 100,000 to this number, which is gonna give us a 1 here. Okay, so far so good. So now we do plus 3 to the power of 3. Okay, so that's 27 as we've established before. But then I multiply this number by 3 times 3 plus 3 over 3, so that's 10. And here inside the brackets is 3 plus 3 divided by 3, so that's 6 over 3, that's 2. So 10 to the power of 2 is 100, and when I multiply 27 by 100, I get 2,700. So yeah, looks like we're on track with this, 27. All right, and then I add 3 times 3 bracket 10, right? So that's 3 times 30, that's 90, minus 3, 87. And 87 goes here. So here we go. This is probably the most useless thing you may have seen on the interweb related to math things, but I thought it's pretty fun. And you know, it doesn't look like that complicated on the board, but when I was trying to do this in my head while I was riding the train, you know, I was just honestly getting so excited about the fact that one can do this with numbers and operations. And yeah, I thought I'd share it with you for kind of a down-to-earth, easygoing third episode of the Grad School Chronicles. If any of you out there watching this are math-inclined people, or you're maybe math graduate students, please let me know what this is called. I'd love to find out. I have a feeling that maybe the task can be made more interesting if we try to use as little of the number 3 in here as possible. So what I mean is that, you know, probably there is a way to condense this, some of these formulas, I guess, to a shorter looking equation, and maybe that could be something interesting that I'll think about later on. But anyway, let me know if you know what this is called. I'd love to find out a little more just for the sake of interest. Thank you very much for watching this episode of the Grad School Chronicles. I know it was a little easygoing and useless, but you know, some things you do in grad school are maybe easygoing and useless as well. Anyway, so have a great rest of your day or evening, whatever it is. It's Family Day here in Canada, and happy Family Day to anybody out there from Canada as well. Take it easy. I'll see you in a week or so with more useful or maybe not so useful content related to the grad school experience. See you then.